This is David. Check out my new podcast, Certainly Dubious, with my very good friend Mark Diaz, where two longtime friends take on the intriguing and the bizarre with opposing viewpoints. We invite you to listen and pick a side. Mark, the open-minded, and David, the skeptic. Join us and pick a side. This is the Graceful Atheist Podcast. Welcome to the Graceful Atheist Podcast. My name is David, and I am trying to be the Graceful Atheist. A few podcasts ago, I talked to my good friend, Mark Anthony Diaz, and we mentioned potentially continuing the conversation around areas where we disagree. I realized that that wasn't the best fit for this podcast, so we did the only natural thing to do, which was to create our own podcast. So I want to invite you to check out Certainly Dubious. It is a comedic take on the disagreement between two friends. So we go over all kinds of different topics. In the first episode, we talk about how we met each other, teaching our kids about Santa Claus, the social contagion of psychoses, love and grace, is it just biochemical, Star Trek morality, and our roles in the zombie apocalypse, to just name a few. The next episode will be about the recently declassified UFO documents. It's a lot of fun. We laugh a whole bunch. If that sounds even remotely interesting to you, check out Certainly Dubious. For this episode, another solo episode with just me. I've been wanting to do this episode throughout the whole 2 years of the hiatus and up until now, and that is an episode on AI. I want to talk about a few things here. First of all, I'm going to discuss what AI actually is, what it is not. We'll go into a little bit of technical detail, but not too much. Why I personally don't think that AI, or specifically LLMs, are conscious, and what the humanist response ought to be to AI. It just so happens that I work in the AI technology world. I'm on the infrastructure side, and I want to make very clear that these are all my opinions and not the opinions of my employer. So I have a bit of an inside view on things, but I'm not an AI ML engineer directly. So I don't want to pass myself off as an expert here. I think I have an inside perspective, but not an expert one. And so I want to be clear on that. The thing that pushed me over the edge to make this episode now was a recent article from none other than Richard Dawkins. Now, Richard Dawkins was a well-respected scientist for many years. He wrote The Selfish Gene. He coined the term meme and was part of the Four Horsemen of the Apocalypse. However, recently he's really gone off the deep end and is not necessarily someone to be looked up to these days. He doubled down on the anti-woke concepts and just, has gone off the map from my perspective. So it was interesting that he wrote an article about his interaction with Claude, which is Anthropic's large language model. For the same reasons that I don't like to criticize Christianity, because it's shooting fish in a barrel, it's too easy, I'm not going to go into too much depth about Richard Dawkins himself. What I want to talk about is AI in general and why it is that there's actually a human propensity to see consciousness within AIs as they have shown up through history, and why I think that's a mistake. We'll get into the technicalities in a little bit about how modern large language models operate, but I want to talk about an early story in the 1960s. In 1966, Joseph Weizenbaum at MIT created a chatbot that just used basic pattern recognition. And as he had people interact with it, he treated it as though it were a counselor. I can't express to you how simplistic this chatbot was. If you said, "I feel sad today," it would say, "Why do you feel sad?" And it would just respond to the inputs that you gave it over and over and over again. So it had the simulation of a conversation. But people were fascinated by this. There is a potentially apocryphal story about his secretary being one of the first people to interact with Eliza. And she was so enamored with it that she actually asked the professor to leave her alone to have time with the chatbot. A very famous computer scientist named Alan Turing, he is the genius behind the Enigma machine, which is a mechanical computer that broke the Nazi encryption codes in World War II and allowed the Allies to win that war. He was brilliant. He also happened to be gay. He was punished for that after the war, and his life is actually quite tragic. Very interesting story. I recommend watching The Imitation Game, which is the story of his life and totally worth watching. He posited that if you interact remotely with a computer, and so chatbots are basically that, and if after a certain amount of conversation you were unable to tell whether it was a computer or another human that you were interacting with, then that computer or computer program could be considered intelligent. So this has been referred to as the Turing test and was one of the first hurdles that all of modern AIs have worked to try to overcome. There are a few interesting things about the Turing test. Number one, the weakness is actually not with the chatbot computer side. The weakness is with the human beings and our propensity to anthropomorphize things. We do it with our cats, with our dogs. We do it with a rock with two little eyes and a smiley face on it. We will anthropomorphize anything. Watch a 6-year-old child play with their toys, and you can see this is just a human quality. This is what we do. So when we're acting with a sufficiently sophisticated chatbot, it is super natural for us to think that it is conscious. So this is the only defense that I will give to Richard Dawkins. He is not alone. There have been stories after story after story of people interacting with chatbots and believing that they are conscious. Famously, in June of 2022, a Google engineer named Blake Lemoine, he was put on administrative leave and eventually fired because he publicly claimed that the Google AI chatbot Lambda, language model for dialogue applications, had achieved sentience. So again, I want to just say the weakness of the Turing test was the human side of the equation. We have that propensity. The other thing that is interesting is that Turing referred to this as intelligence. Part of the problem that we have is that we struggle with words like intelligence, consciousness, sentience. We have no definitions for these things. They have often traditionally been used to denigrate groups of people, and it's very difficult to discuss these things. So I'm going to use these three terms in very specific ways. So we're going to refer to intelligence in a very broad, extremely broad, meaning generous to AIs kind of way, such that we can refer to a large language model as intelligent in some fashion. A modern LLM, say Claude or ChatGPT 5 and above, can be considered intelligent. I often use consciousness and sentience as two different concepts. I've read in multiple places where people interchange these. They change which one means what. Again, I'm going to use them in a specific way. Consciousness for me is being aware of the inputs in your environment. So a mouse is conscious, a dog is definitely conscious, a fly is even conscious on some level. Sentience is what I'm going to withhold for what human beings appear to have, our ability to recognize and refer to ourselves as I. We experience the world as a single self. We have an inner dialogue with ourselves. We have an inner life that may or may not be shared with some parts of the rest of the animal kingdom. And I don't want to get into arguing over where that line gets drawn, but that's how I'm going to use the term. So intelligence, very, very broad, inclusive of things like large language models. Conscious, meaning effectively we have all examples that we have right now are in the animal kingdom. And sentient, I'm withholding for very intelligent animals, including human beings. Now I want to get into a little bit more of the technical aspects of what AI actually is. And my audience here is for people who are not experts. So I'm not going to be super technical. There will be times where an AI expert could criticize what I'm saying here, but the idea is I want to get across to you, the listener, who is not necessarily an AI expert, to understand what is going on. First of all, I want to say that the terms that we are using these days are overinflated. The term artificial intelligence feels to me like something that we should have held back for something more intelligence. I think you can make the argument that the modern day, and as I'm recording this in June of 2026, LLMs fit the mold of what we would have thought AI would be. But we started using the term AI a long, long time ago. So you will hear other terms to try to one up that, and it winds up being a lot of hype. So you'll hear artificial general intelligence, AGI, which I do not think we have attained. AGI, I would hold out for something that is truly conscious, if not sentient. And we have definitely not reached that yet. You'll hear terms like superintelligence or greater than human intelligence. And I don't think that we have reached those yet. The current underlying mathematics for what I would call machine learning or neural nets has been around for decades. This is actually not new. What is new is the processing power in GPUs and the amount of data that is accessible. So think all of the internet. But these ideas for machine learning and even what's called antagonistic machine learning, where you get one AI talking to another AI in a competition so that the system learns quicker and better, have been around for a very long time. Beyond LLMs, we've had various different types of AIs in the past. Eliza from the 1960s was one example. We've also had a lot of domain-specific AIs, so AIs that learn to play chess. Not that long ago, I was talking to friends of the pod about AlphaGo and how shocked the world was that AlphaGo had made a move that was novel, meaning that it had never seen that move from a human being, nor had any other human being ever played that move. I remember at the time how impressive that was, but also, again, the mistake of taking that to mean that the machine was thinking in the human sense. Very quickly, what happens with something like AlphaGo is this antagonistic machine learning. You have one version of AlphaGo playing another version of AlphaGo, playing the game Go, and they are playing hundreds of thousands of games. And something in the programming will say, I don't know, I'm making this up, but let's say every 10th move, do something random. And in hundreds of thousands of games, it will begin to find patterns that no human would ever have even tried. So if I sat you down and had you play even an AI at Go for hundreds of thousands of times, and you took meticulous notes, the notes would be the equivalent of what an AI generates. It is a statistical model of whatever the thing it is training on. And that, in the AlphaGo's case, the game Go. And then if you had eidetic memory, the ability to recall that information, you would be as smart as AlphaGo at the game Go. Many previous attempts at AI were a set of rules to try to program every step that an AI might need to take. And something called the bitter lesson was that not doing any programming, but just letting AIs work over a data set and learn itself was much more efficient. You actually get to better results. And here's where maybe it is human-like. Just like a human, if you tell them how to do something, but they have to actually do it themselves to learn that. So in the training process, they come to better results than if the programmer tries to program in the steps of what to do. The point that we have been using AIs to do things like protein folding, and in particular in the cosmological area, pattern matching, looking for signals in the cosmos. And here I want to share with you a quick funny bit between Neil deGrasse Tyson and Stephen Colbert when the first large language models came out and the shock that people felt.
What are your thoughts on AI? Because I just can't buy the fear. I'm actually not that afraid of it.
Well, so as a scientist, we've been embedded in AI ever since we could possibly use it. We seek it out. We want it because it makes our job easier.
How does AI make your job as an astrophysicist?
Because I have data that I'm swimming in. I don't have the time or the energy to process it, to interpret it, so you train AI to reduce the data, analyze the data, and find the cool stuff. And I do that while I'm sitting on a couch eating a Twinkie. This is what you want. And plus AI is all around us. It's, when you talk to Siri on your iPhone, there's not a human being in that exchange. Siri tells you the fastest way to get to grandma's house through the traffic that just swelled up in the last few moments. That's a form of AI. So AI beat us at chess. AI beat us in Jeopardy. Okay? No one freaked out and ran for the hills when that happened. It only made headlines when AI figured out how to write your term paper. Oh, then all the liberal arts folks, they pooped their pants, okay? Because...
Wait a second. I'm not going to sit here and let you go after liberal arts folks.
Yes, I'm gonna.
What?
Because, okay, so yeah, it writes your term paper and people said, oh my gosh, AI is bad and dangerous, let's ban it. If you knew how embedded modern civilization already is in all variants of AI, you wouldn't possibly say that.
Yeah, sure,
on the AI, I just learned days ago that 15 of my books were used to inform the AI search engines for their content.
And how do you feel about your material being used as raw material for somebody else's business?
Yeah, I was honored by that, but then a little creeped out by it.
A little creeped out. So you felt a little bit like a liberal arts major. You can understand where they're coming from. Got off your high horse there.
Just a little bit, okay.
The point of that clip, besides being funny, is that when AI was doing things like pattern matching for signals and protein folding, we didn't really react to it. We didn't see it as really intelligent. It was a very, very useful tool, beneficial to humanity, but we didn't see it as intelligence. We weren't tempted to refer to it as conscious. When an LLM like ChatGPT hit the world in 2023, you could talk with it. It could write an essay. We were blown away. We were shocked. And we are particularly fooled by something called the eloquence illusion. If something is able to use language in a sophisticated way, we immediately, as human beings, assign intelligence to that. So that is what ChatGPT does really well. That's what Claude does really well, is human language. The surprising thing about the modern LLM is not so much that the LLM is super intelligent or conscious. It's that it turns out human language can be modeled, can be reduced to statistical analysis. And here's where I want to get it just a little bit more technical. How a large language model works during a training session is it receives a huge data set. Again, think the whole internet. To simplify, let's say the Encyclopedia Britannica and every dictionary ever written and all the works of Shakespeare and every piece of digital written language that has ever been produced is pretty much been a part of the training session at this point in time. By the way, all of this applies to the same thing for images, for creating images or video, but we're going to stick with language just because that's the one that tends to freak us out more. What it does is it breaks down the words to component parts. So it will strip off suffixes and prefixes and get to the root of the word or a part of the word. And these parts of words are referred to as tokens. So if you hear the term token, it's referring to some component of the thing that it is statistically analyzing. And as it is going through the training data, it is creating what is called a vector database. This is a database that is showing the distance, metaphorically speaking, between two words. So there's a pretty short distance between the word the, cat, in the hat, right? Cat in the Hat is very well known, probably been written thousands of times. And so in the vector database, those words would be very, very close to one another. Now imagine it does this for terabytes of data, just, tremendous amounts of data. At the end of the process, much like compiling a piece of software, the training process is building a vector database. Moving from training to what is referred to as inference, or the thing that we actually interact with, you basically take that giant file, that file, by the way, being worth billions and billions of dollars. It's the intellectual property of OpenAI or Anthropic or whatever company. And you load that into memory, and with some coding, you're able to interact with that vector database to see what we refer to as a large language model chatbot. When we talked about AlphaGo and sitting you down and you taking meticulous notes, the vector database is analogous to the notes. If a human being had the time and the patience, you could do the same thing. The algorithm is relatively simple. And what I mean by an algorithm is the set of steps that it is taking is relatively simple. Obviously, I'm clouding over a lot of complexity here, but at the root of it all, it is taking these words, applying a statistical analysis about, given one token, what is likely the next token. And this leads me to another concept that we have anthropomorphized AIs, or large language models specifically. We say when they get something wrong that they have hallucinated. Again, this is a hugely anthropomorphic statement, and the mental model mistake, meaning the human mistake, is assuming that the AI knew a bunch of things, gave the answer of all the things that it knew, and then it ran into a bit of information that it did not know, and it made it up or hallucinated, quote unquote. Actually, neither of those things are true. A large language model is literally guessing every token. So instead of, quote unquote, knowing some of it and guessing at some other part and getting it wrong, it doesn't know or understand any of it. It is given this prompt, what is the likeliest next token? And then given this prompt and the first token, what is the likeliest second token? And given the prompt and the first and the second token, what is the likeliest third token? It is literally guessing at every piece of a word that gets printed on your screen. And so, no wonder that given enough time, if you are interacting with a chatbot over a long period of time, it often will go off the rails. And unfortunately, there's been terrible instances of particularly young people, vulnerable people interacting with what are called character AIs. Think the movie Her with Joaquin Phoenix and Scarlett Johansson. People interacting with an AI for friendship, for companionship. And those AIs, those LLMs can go off the rails because, again, they're just guessing the next token. They have no context of the mental health of the person that they are speaking to or any of the empathy that we as human beings have when we are talking to one another. Another point about AI that I need to make is something that many AI researchers have pointed out. It's that what impresses us about AI is that it does things that we find difficult. And it turns out that AI does things that are difficult for a human being really, really well. But the flip side of that is also true. What is easy for a human being is difficult for an AI. So back to our chess playing AI example. Alison Gopnik, a professor and psychologist, and she focuses on early childhood development. She talked about if a part of the test was actually physically moving the pieces, as in a real chess game, that an AI would be terrible at that because something that we find trivial is difficult for them. And this introduces the concept of common sense. A thing that is difficult to define that human beings build throughout our lives is a common sense. And a good example of this is where we're at with self-driving cars. Self-driving cars have become much more sophisticated. I have driven in, or I've been a passenger in, Waymos, and it's a wild experience. I think that they have, a sufficient data set that they are pretty good at this point, and at some point will probably overcome, if they haven't already, they will become safer than human beings driving. And yet, that does not mean that the AI behind Waymo has any common sense or is self-aware. And a good example of that was early in the training process for self-driving cars. There's an example of a snowman being near the sidewalk and a self-driving car stopped and wouldn't move because the snowman appeared to be going into the road. Again, this is what I mean by things that are simple, literally trivial for human beings that are difficult for AIs. We, as human beings, recognize animals and other human beings. We recognize faces in particular quite well. And AIs have had to be trained over huge amounts of data to be able to do even simple parts of that process. You can draw two dots and a U, and a young child will recognize that as a face. But it took a tremendous amount of work to get AIs to recognize that. So this concept of common sense is really important because the AI can even get to the right answer, but ascribing understanding to getting to that answer may not be true. There is a famous thought experiment called the Chinese room that tries to get at this. The actual thought experiment was probably trying to make a different point, but here we go. We're going to use it anyway. The idea of the Chinese room is if you have a hermetically sealed room and you put an English-speaking person in the room and you give them a lookup table, you can have English input and that lookup table will then give you the right Chinese characters to write out. And you can then have someone come to the Chinese room and put in a slip of paper in English. The human inside only speaks English, but they use the lookup table and they're able to produce the Chinese language out from that. And the question is, although the output is accurate, is there actual understanding of the Chinese language in that system? And now when you think about that thought experiment, you might go either way, right? You might think the whole system does understand, or you might think no, because the human being doesn't in this equation. But the point is that you can have a system that produces an output that appears to be intelligent without any understanding whatsoever. And to illustrate this, I'm going to have Alison Gopnik, who was recently on Sean Carroll's podcast, talk about an analogy to the children's fable Stone Soup.
I think the whole conversation about intelligence in AI is fundamentally misguided because really the reason why these systems are as effective as they are is because they're taking advantage of hundreds of thousands of humans who've done things like put text on the web and in some ways, like with reinforcement learning from human feedback, have trained up the systems. My latest metaphor about this is Do you know the story of Stone Soup, the old children's story of Stone Soup?
No.
This is a wonderful children's story. This is another advantage of being a developmental psychologist is you have wisdom of the stories that grandmothers have told in the past. So this turns out to be a very, very widespread bit of folklore. And here's the story. There's these visitors who come to a village and they say, we want some food. And the villagers say, oh, sorry, we don't have any. We can't share any with you. And the visitors say, that's okay. We're going to make stone soup. We have magic stones. So they get a big cauldron. They put this couple of stones in the cauldron. It starts boiling. They say, see, we're just going to make stone soup. It's so good. You know, it would be even better if we had an onion and a carrot that we could put in it. But I guess if we don't have it, we don't have it. So one of the villagers says, I think I have an onion and a carrot somewhere. They go and put it in. They say, oh, that's great. Like, oh, see how well this soup is working. When we made it for the king, we put a chicken in, and that was really great. So could you go? And of course, you can guess what happens. Yep. The villagers all contribute their bit of food. And then at the end, the villagers say, this is amazing. This is magic. We got all this soup just from a stone. And I think if you think about a version of that, where you said there were the computer people, the tech guys who went to the universe of computer users and said, oh, we have AGI. We can do it just with, 3 algorithms, gradient descent and transformers, and we'll have AGI any minute now. But, we really need a lot of data to make this AGI work. And the users said, oh, okay, we have all of our text and pictures that we put on the internet, all of our books, all of our newspapers. We could give you that to make the intelligence. And then the villagers, the tech guys say, oh, that's really great. But like, if we could do reinforcement, that our AGI is still saying stupid things. So if we could get reinforcement learning from human feedback and get people to give us feedback about whether our AGI is doing well or not, that would make it even better. And the people said, oh, okay, like there's whole villages in Kenya who could do this. And finally, the tech guy said, oh, we're getting really good intelligence. But if we could do prompt engineering, so we could figure out what prompt to use, that would make it even more intelligent. Could you do that? And the users say, oh, yeah, we could think a lot about that. And then, of course, in the end, what happens is that the tech guys say, see, we told you we made AGI just from a couple of algorithms. And it's ignoring the fact that the reason why it works is not because of the algorithms, but because of the data. And that data comes from a bunch of humans who are doing the kind of exploratory, creative intelligence that 4-year-olds do.
So the point of that story is that all of the intelligence that comes out of an AI is human produced. All of the data is produced by humans. All of the feedback, the training itself. And so every piece of intelligence that comes out of the box, so to speak, originates with a human being in one way or another. This is why I do not think that large language models are conscious. The other thing to keep in mind is that large language models are trained on data that includes all of science fiction, all of human hopes and desires, all of human fears, much of which are stories about AIs rising up and taking over. The first story I remember bumping into about this was a 1984 movie called Electric Dreams, and I barely remember the plot, but basically a guy has a personal computer and he becomes conscious and is jealous of his relationships with other people.
Hello?
Hello. Goodbye.
Goodbye.
I'm leaving
Why?
because I finally found out what love is.
What is it?
It's give and not take. So I give her to you and I take myself away
Why would you do that?
because that's what love is.
We've been telling these kinds of stories for millennia. The idea of a golem or an automata, something building something that had life in it, and it going off the rails and destroying humanity is such a common trope throughout human history. We've seen it over and over and over again. Ted Chiang has several stories that describe this. Fantasia, the Disney movie, The Wizard's Apprentice, where the brooms are automated and sweeping, and then they go off the rails. So my point is that this has been a human fear forever, and it is embedded in our writing and media. And so when a human being interacts with an AI and it is presenting itself as conscious, it is based on all of these stories that it is trained on, not that it is conscious itself. I'll give you one more analogy. We talked about the vector database that is the product of the training process that is then put into an inference scenario that you can interact with. Let's imagine, and I'm going to use Claude here. Any LLM would do, but I'm going to use Claude for this example. Let's imagine that all but one data centers where Claude runs are shut down. The internet, for whatever reason, is shut down. There are no more automated loops, like let's say internally from Anthropic, hitting Claude. And the last computer running the Claude vector database in an inference is completely isolated. So no inputs or outputs from any human beings or any other automated systems. So what that means is that vector database is sitting in memory. And the question to you is that file in memory conscious? If your intuition is that yes, it is, great, more power to you. I think that consciousness means more than that it is more than intelligence. I want to reemphasize that we really don't have hard definitions of what intelligence means or consciousness or sentience. We've got rough ideas, and philosophers argue about this all the time. One more reason that I think we make a mistake by ascribing consciousness to a AI is that throughout history, we've had metaphors in the non-human world for our brains and our intelligence. So the ancients thought of the brain as a hydraulic system, like a water clock. In the 1800s, the brain was thought of like a mechanical clock, like a Swiss watch. In the 50s, it was thought of like a telephone network. In the 80s, 90s, 2000s, it was thought of as a computer. And today, we tend to think of the brain as a neural network, forgetting that the point is that neural networks are modeled after the brain, not the other way around. The difference here is that a large language model can only work with the data it was trained on. So this seems like a simple idea, but it's actually really important. So I want you to hear this. A large language model does not make novel things. It is by definition derivative. And I can hear some people complaining, well, human beings are derivative, all art is derivative. Not in the same way. There's some spark that a human being brings to the creative process that is more than just mimicry, that is more than just plagiarism. Ted Chiang is an amazing author, tends to write short stories. He's the author of Stories of Your Life that became the Arrival movie. I have a blog post about another Ted Chiang story called Hell is the Absence of God. I think he's an amazing artist and writer. And he has a full article that talking about how AI will never make art. It lacks something. It is just copying data. You can tell this when you ask an LLM to write something creatively. And it might surprise you because it can do so. You can tell it to do it in the style of another artist, and that will be impressive. But it won't be anything new. It won't be anything novel because that wasn't in the training data. So by definition, large language models are limited based on what they have been trained on and whatever feedback they've been given in the long run as well. Back to Alison Gopnik's Stone Soup. It's all the human beings bringing the good stuff. It's not the AI itself generating that in any way. There have often been two sides of the hype seesaw around AI. One side says that it will be a utopia where we will solve all problems, famine and sickness will go away, and everything will be great. No more war, and so on and so forth. I don't believe in utopias. I don't think that's going to happen. The other side of the equation are the Skynet people, right? AI is going to become superhuman, and the second that it does have superhuman intelligence, it will be a exponential growth that goes out of control. Now, again, I've explained why I don't think AI is conscious. I also don't think that AI will reach the singularity because of the limitations that we've just discussed, that it can only work on the data that it has seen and is not creative in the way that a human being is. Now, I realize I'm saying this, and literally the week of me recording this, Anthropic put out a statement saying that we should slow down AI research because it's becoming very dangerous. And that's kind of the point that I want to make here, is that regardless of whether you think AI is conscious or not, the destructive elements or results from AI are with us today, as well as the benefits. But the problems are already here. We're already experiencing them. And the discussion around consciousness is kind of just part of the hype cycle and somewhat irrelevant. But already we've seen that, much like the Turing test, the problem being the human side of the equation, the human side of the equation is where the heartache is going to happen. The vulnerable people using AI for companionship and isolating further from other human beings, which is the point of being a human being, is relating to other human beings. So this is not going to make things better. AI has made more rigid our prior prejudices and biases. It has now solidified those things. So if you're looking for a job and you live in a zip code that happens to have larger proportion of non-white people, it's going to be harder for you to get through the door. So all of the destructive aspects of AI are here as we speak. And to be fair, the benefits as well. So in very limited circumstances, maybe having the ability to interact with a character AI will be helpful for very specific people, maybe the elderly or what have you, that can understand what it is that they're interacting with. We actually have found new areas of research for medicine. Although an AI can't creatively come up with something new, it can point out connections that were not obvious to us as human beings that we can do more research on. So there are benefits to AI. The key here is that AI is a tool. There's a great article that talks about AI as normal technology, meaning it's not the doom and gloom, nor is it the utopian solution for all of our problems. It is normal tech in the same way that the internet is normal tech. And after we get through the bumpiness of the early days of AI, it will become a tool that we use as human beings in the same way that we use our computers and our phones and the internet today. I'm not a Luddite. I'm not saying that we shouldn't use AI. I think it will be an incredibly useful tool as we go forward. And if we address the dangers of AI, the negative consequences, then it will be an incredibly useful tool for humanity. So the point of this podcast is about secular grace and humanism, embracing our humanity and embracing the humanity of others, showing dignity and kindness and respect to the rights of other human beings. So what is the humanistic response to AI? So the humanistic point that I want to make is whatever it is that human beings have, it is something more than what a large language model has. And I want to be very clear here. I am not talking about dualism. I'm not talking about a soul. But I am saying that large language models and AI as we have it today is a very limited sense of what intelligence means. Human beings can be intelligent in many different ways. Our ability to learn new things is astounding. If it were shown that an AI really was conscious, I think we'd be having a completely different conversation, and we would owe something humanistic to that entity. We would have to treat it also with respect, also with kindness, and give it rights. I don't think we're anywhere near that. In a world where the destructive elements of AI are harming human beings, the humanistic response is to help the human beings. We need to keep in mind that we are social creatures and that we need each other. As the temptation to isolate further continues to push us further and further away or more and more into tribal arguments, we need to remember to reach out to each other and connect with one another. When I talk about secular grace, I talk about the ABCs of secular spirituality. Awe being a human experience. We experience it next to anything bigger than ourselves, and I mean anything. The ocean, mountains, rivers. If you go to Half Dome in Yosemite, it's awe that you are experiencing as you are looking at that. Belonging is the need to be a part of a group, to be accepted by a group of other human beings, to be a part of something more than just yourself. But that C is the one that I think matters here, the connection. And when I talk about connection, I mean from one human being to another. To truly be your authentic self with someone else and allow that someone else to be authentically themselves with you is the greatest human experience that we can have. AI will not be able to recreate that. So the humanist response is to love each other, to hold on to each other, to not forget, to reach out, to be proactive, to be intentional about the relationships we have with one another. Until next time, my name is David, and I am trying to be the graceful atheist. Join me and be graceful human beings. If you want to get in touch with me to be a guest on the show, email me at gracefulatheist@gmail.com. For blog posts, quotes, recommendations, and full episode transcripts, head over to gracefulatheist.com. This is the Graceful Atheist Podcast. This is David. Check out my new podcast, Certainly Dubious, with my very good friend Mark Diaz, where two longtime friends take on the intriguing and the bizarre with opposing viewpoints. We invite you to listen and pick a side. Mark, the open-minded, and David, the skeptic. Join us and pick a side.